Okay, this is the solution for the Edexcel S1 potential paper. Question 1, so it's a normal distribution question. We need the probability of x less than 15. So that is z less than 15 minus 30 over 5. That is z less than minus 3, which is same as 1 minus probability of z less than 3. And that works out to be 0.013, and that is 0.13%. Part B. Probability of x between 35 and 20, that's same as probability of x less than 35 minus probability of x less than 20, and you use the same formulas and you end up getting to the last stages where it becomes probability of z less than 1 plus probability of z less than 2 minus 1, and then that works out to be the answer, 0.8185. Part C. So we want the probability of x greater than 30 to be 0.01. So z greater than 30 minus mu over 5 to be 0.01. So that means z less than 30 minus mu over 5 is 0.99. And then you simplify the same way, and you get mu equals to 18.3685. So the mean time is 9:18 a.m. That's question 1. Now question 2, sorry. So we have probability of P is 0.5, probability of Q is 0.42, probability of P dash union Q dash is 0.86. So I've drawn a Venn diagram here. So we are given probability of P dash union Q dash 0.86. That is same as probability of P and Q all dash, which is 0.86. So that means probability of P and Q is 0.14. So from that you could complete the diagram, the Venn diagram. So to get the probability of P union Q all dash, it's obviously 1 minus probability of P union Q, which is 0.22, as you see from the Venn diagram. And probability of P dash given Q is same as probability of P dash and Q over probability of Q, which is 0.28 or 0.42, which is 2/3. And probability of Q dash given probability of P is equal to probability of Q dash given P over probability of P, which is 0.36 over 0.5 from the diagram. So that is 18/25. So that's question 2, guys. Here's the full question. I'll just hold it there for a bit. Okay, and question 3. Okay, so we have x equal to t minus 50 over 10, y equals to m plus 40 over 100, and then you complete the table as shown below using those formulas, the coding formulas. And then to get sxx, syy, and sxy, I worked out the sum of x, sum of y, sum of x squared, sum of y squared, and sum of xy, and then use the formulas to get the values. Okay, I just used the calculator. And the PMCC, so that is sxy over square root of sxx, syy, and that works out to be 0.834. So the PMCC for t and m is also 0.34. Okay, now to get the regression line, b is equal to sxy over sxx, which is 0.067. And x bar is 2.383, y bar is 1.1516, so a equals to y bar minus bx bar, which is 0.9919, and the equation of the regression line is y equals 0.9919 plus 0.067x. I think there's one more part to this, actually 3 more. So part F is the regression line for m on t, so so you just simply replace y by m plus 40 over 100 and x by t minus 50 over 10, and you just simplify and you end up getting m equals 25.69 plus 0.67t. When t equals 150, m equals to, basically you plug the value in and you get 126.19. So the estimate is not reliable as 150 minutes is outside the data range, so we are doing linear extrapolation, which is not obviously reliable. Okay. Now, question 4, part A. So all the probabilities add up to 1. So what I did is I added the 2 fractions with the denominator 8, and the other 2 I put under denominator 2k, so it becomes 1 plus 2. So you end up getting this quadratic at the end, 2k squared minus 14k plus 24 equals 0, and if you half that, it will be k squared minus 7k plus 12. So when you factorize it, k equals to 3 or k equals to 4, so obviously k equals to 3 is proven. And part B, so probability of x greater than or equal to 4 is same as probability of x equal to 4, probability of x equal to 5, and probability of x equals to 6 added together. So you add them up and you get 5/8. Okay, and So I've completed the probability distribution again. So 3, 4, 5, 6, 3 8s, 1 8, 1 6, 1/3. So expected value of x is 4.46. E of x squared is 21.5416 recurring. So the variance of x is e of x squared minus e of x all squared, which works out to be 1.65. You just basically plug in the values you worked out into the formula. And variance of 4x minus 1 is same as 4 squared of variance of x, which works out to be 26.4. And e of 3x plus 2 is same as 3e of x plus 2, which is basically that. And then you plug in the formula and you get 15.38. Question 5. Okay, I mean, question 5, I have completed most of it. I just left out the histogram and the standard deviation at the end because I think it's quite easy to do and it's just long, so I didn't do that. So anyway, so I completed the column. Okay, so I've completed a few extra columns here. So these are the two given in the question. So I completed the x column and the fx column. So I used that to get the mean. Okay, so the mean works out to be 2,484 and 95 pence. Now to get the median, so the median term is 515 plus 1 over 2, which is 258 term. I'm using the n plus 1 formula, guys, and then I'm using interpolation to work it out. So you got the Q2 here, and you got the two boundaries. So 258th value is in this class here, 1500 to 2500. But because the 1500 is kind of overlapping here, not overlapping, I mean that's 1500 here, 1501. So the boundary is 1500.5, and this boundary is 2500.5. So you use the formula and work out Q2. And to get the Q1 and Q3, use the same thing. Okay, so those are the values. And interquartile range is Q3 minus Q1, and that's the amount. Okay. So I've left the last bit out of it. Okay, so I left the, so I did complete the class width and the frequency density, but I didn't draw the histogram. You can just draw the histogram using those, that's not a problem. And also I left the standard deviation, you just plug in the value to the formula. Okay, so that leaves us to the last question. So it's a normal distribution with mean and standard deviation not given. However, we are given two separate probabilities. So probability of x greater than 65 is 0.7 and probability of x greater than 55 is 0.9. So I've drawn the two diagrams here. And then you work out two equations by simplifying. And you get mu equals to 65 plus 0.5244 sigma, that for equation 1, and mu equals 55 plus 1.2816 sigma for the equation 2. So equation 2 is equal to equation 1 because they're both equal to mu. So you get sigma equals to 13.2, so therefore mu equals to 71.93. So the question we want is probability of x between 70 and 75. So that's same as probability of x less than 75 minus probability of x less than 70. And then you simplify using the z values, and you end up getting this situation: probability of z less than 0.23 minus probability of z less than minus 0.15. So this is minus 0.15, you're going to split it into 1 minus probability of z less than 0.15. And then you plug the values in and you get 0.15106, and the percentage is 15.06. And that is the end of the solutions, guys, and I wish you best of luck with the exam.